Hello students, here is Rumit Mystery. Our chapter that is going on, that is electrochemistry, and before this we have completed total 3 lectures of electrochemistry. First lecture was related to Daniell cell. In the second lecture we have seen electrode potential and EMF of cell, and we have solved numericals related to standard conditions. The third lecture was related to Nernst equation. In that Nernst equation we have solved several numericals also, and today we are going to learn about standard hydrogen electrode. Today we are going to learn about standard hydrogen electrode. It is also known as SHE, S-H-E, SHE. Okay. Fine. What is the standard hydrogen electrode? Standard hydrogen electrode, you might be remembering that in Daniell cell we have taken 2 half cells. One was anodic half cell, another was cathodic half cell. यहाँ पे left hand side पे anodic half cell, on right hand side it was cathodic half cell, and those both the cells were connected with salt bridge. Both of the half cells, suppose in left anodic half cell, that both of the half cells were having its standard reduction potential. Now this standard hydrogen electrode, it is said to be a reference electrode. Standard hydrogen electrode is known as reference electrode, and it is said by IUPAC. It is a reference electrode as said by IUPAC. It is also known as gas ion electrode. In Daniell cell we have seen that suppose on any of the electrochemicals we have seen that one electrolytic solution is taken, and in that one metal rod is being immersed. This electrolytic solution is containing metal ions of the same metal whose electrode is being immersed. So over here we were using Mn positive. So this was metal ion electrode. It is also known as metal ion electrode. Why? Because from metal ion was getting oxidized by losing 2 electrons, and suppose if from metal ion by gaining electron, if metal is formed, then also it is known as metal ion electrode, right? In the same way over here in standard hydrogen electrode it is known as gas ion electrode. That means over here gas and formation of ions is involved. That means from hydrogen H plus ions is formed. From hydrogen gas H plus ions is formed. Okay. Next, it is used as a reference electrode, and with its comparison to another electrode we can find the potential, that is standard reduction potential or standard oxidation potential of another electrode. See what it is telling. It is used as a reference electrode. That means if on cathode we are taking one metal ion electrode, and on anode we are taking this hydrogen electrode, then this hydrogen electrode is used as a reference electrode. That means on the basis of this electrode, the standard reduction potential of the another electrode is found out. Now as said by IUPAC, the standard reduction potential of hydrogen electrode is assumed to be 0. Why? Because on the basis of this, with the reference of this hydrogen electrode, we are going to get the value of standard reduction potential of another electrode. That means out of both the electrodes, one of the electrodes should have some value, and that's why IUPAC said that let us assume the standard reduction potential as well as standard oxidation potential of hydrogen to be 0. Okay. Now this, with the help of this reference electrode, the value of another electrode that we are getting, that is comparative value. It is not absolute value. It is comparative value, because by comparing it with this hydrogen electrode we are getting the standard reduction potential of another metal electrode. See over here, it is used as a reference electrode, and with its comparison to another electrode, we can find potential, that is standard reduction potential or standard oxidation potential of another electrode. It does not give absolute potential, as I told, it does not give absolute potential, it will give you comparative potential, that is standard reduction potential or standard oxidation potential, because of another electrode with reference to standard hydrogen electrode She. It acts as, another important point of this electrode is, it can act as anodic half cell as well as cathodic half cell. It can act as anodic half cell as well as cathodic half cell. See, it can as an anode half cell as well as cathode half cell. That means you can take on any of the side. You can take on anode as well as on cathode. Its standard reduction potential as well as standard oxidation potential. SRP means standard reduction potential. SOP means standard oxidation potential. Is assumed to be 0. It is not 0. It is assumed to be 0, because with the help of this electrode, we are going to get the reduction potentials of another electrodes. Why? Because we are comparing it. On the basis of this comparison, we are getting the values of another electrode potential. That's why E naught of H plus by 1/2 H2 by 1/2 H2. Okay, that is standard reduction potential of hydrogen, that is equal to standard oxidation potential from here 0 to +1. That means oxidation is happening. The standard oxidation potential is 0. Standard oxidation potential is 0. Standard hydrogen standard reduction potential as well as standard oxidation potential of hydrogen is assumed to be 0. राइट IUPAC ने भाई बोल दिया कि एक इलेक्ट्रोड को तो 0 देना ही पड़ेगा, और उसमें हाइड्रोजन इलेक्ट्रोड है, स्टैंडर्ड हाइड्रोजन इलेक्ट्रोड, राइट, और उसका वैल्यू हम 0 वोल्ट लेंगे, 0.0 वोल्ट, 0.0 वोल्ट. ओके, क्या है भाई? फर्स्ट ऑफ ऑल, इट इज अ रेफरेंस इलेक्ट्रोड विथ, as said by IUPAC, it is also a gas ion electrode, because from gas it is forming ion, or from ions it is forming gaseous molecules. It is used as a reference electrode, and with its comparison to another electrode, we can find potential, that is standard reduction potential or standard oxidation potential of another electrode. Now the value which we are going to get of the value of potential, that is standard reduction potential or standard oxidation potential of another electrode, which we are going to get with the help of this reference electrode, that will be comparative value. Always remember, because we are comparing it with hydrogen electrode, and hydrogen electrode is our reference electrode. It is our reference electrode, right? So another important point, it can act as anode half cell as well as cathode half cell. Its standard reduction potential as well as standard oxidation potential, it is assumed to be 0. देखो 0.0 volt standard reduction potential, H plus to H2, H2 to H plus. This is standard oxidation potential. This is standard reduction potential. It is assumed to be 0. Okay, fine. Now let us see how we can represent it. If, let us first of all, let us see its construction, कि भाई इसका construction कैसे होता है. You can take a screenshot, या इसको note down करना है तो आप note down कर सकते हो, pause करके screenshot भी ले सकते हो आप. It will be helpful to you. Okay, thank you. बहुत ही बढ़िया इलेक्ट्रोड है, बहुत ही बढ़िया इलेक्ट्रोड है ये. लेट अस सी इट्स कंस्ट्रक्शन. In the construction of standard hydrogen electrode, one beaker is taken. भाई वेसल तो देना ही पड़ेगा ना, केमिस्ट्री है. केमिस्ट्री है, वेसल के बिना तो कुछ काम होता ही नहीं. One beaker is taken. In that, let us immerse one glass jacket. One glass jacket. One glass jacket is immersed in it. Here there is two outlets. One outlet is for one opening space. From here, pure hydrogen gas at 1 atmosphere is being inserted. From here, excess of H2 gas comes out. In this, one platinum wire is immersed. Platinum wire, that is our, it can be written as platinum electrode or platinum wire. At the end of this electrode, platinum black foil is being attached, connected. Platinum black foil is being connected, right? And this beaker, we are going to take HCl solution. HCl solution. Whose molarity is, let us say, 1 molar. यहाँ पे assume कर देते भाई 1 molar इसकी molarity है, concentration is 1 molar, right? Now what will happen in this electrode? What will happen in this electrode? Whenever this pure hydrogen gas, is immersed, when glass tube insert करते थे यहाँ से, whenever this hydrogen gas is entering this cube, this is our glass jacket. Whenever this hydrogen gas is entering in this tube, and it will fall on this platinum black foil. So when this hydrogen gas, it will fall on this platinum black foil, क्या होगा यहाँ पे? हाइड्रोजन गैस का एड्सॉर्प्शन होगा. क्या होगा यहाँ पे? हाइड्रोजन गैस का एड्सॉर्प्शन होगा. हाइड्रोजन गैस, it will either adsorb, we cannot say, but and it can absorb also. Either hydrogen gas will adsorb or absorb. What is adsorption? Adsorption means it occurs on the surface phenomena, and absorption means hydrogen gas will penetrate into the bulk phenomena. It is a bulk phenomena, right? It is a bulk phenomena. Okay. तो यहाँ पे हाइड्रोजन गैस का एड्सॉर्प्शन होता है या तो एब्सॉर्प्शन, both of them occurs. And the remaining hydrogen, excess of hydrogen, it is not like that every hydrogen molecule, gas molecule will be getting absorbed on this platinum black foil. The excess of hydrogen molecules will come out. The excess of, यहाँ से bubbling in the form of bubbles. Even it can go over here also. And from this it can travel through this also and can come out. From this, excess of hydrogen gas comes out, right? So these are the bubbles of excess of hydrogen gas. Now what is happening with these hydrogen gas bubbles? These hydrogen gas bubbles And apart from that, this aqueous solution, it is also containing H plus ions. It is also containing H plus ions in the solution. In the solution there are H plus ions because it is HCl solution, right? So, and as the concentration of HCl is 1 molar, over here the concentration of H plus will also be 1 molar. The concentration of H plus will also be 1 molar. Now this hydrogen gas and this H plus ions present inside the solution. This hydrogen gas and the H plus ions present inside the solution, they will attain equilibrium. H plus electron. Let us balance it. Aqueous. Okay. They will attain equilibrium. That means as we are going from left to right, loss of electron, that is oxidation. From right to left, gaining of electron. It is reduction. Right? So this is the working of construction and working of standard hydrogen electrode. This is the construction and working of standard hydrogen. Now, is it being represented? The representation. If it is used as cathode, if SHE, that is standard hydrogen electrode, is used as cathode, then how is it represented? How it is denoted or represented? It is represented as cathode reduction will occur. So H plus aqueous, suppose it is X molar, hydrogen gas 1 bar or 1 atm, and platinum. H plus ions to hydrogen gas and it is attached with platinum, it is occurring with on platinum. Second, if standard hydrogen electrode is used as anode, then it is represented as on anode what is happening? Oxidation is occurring. That is, oxidation is loss of electron. Hydrogen electron लूज करेगा. तो क्या है भाई? प्लेटिनम, हाइड्रोजन गैस 1 bar or 1 atmosphere, whatever, to H plus aqueous X molar or 1 molar. Here we have taken 1 molar. So for this we'll be writing 1 molar. Over here also we can write 1 molar. But if the solution concentration is different, then at that time what will happen? Its concentration will change, right? So this is the representation of standard hydrogen electrode when it is used as anode, as well as when it is used as cathode, right? Fine. Now, related to this standard hydrogen electrode, in your exams many numericals can also come. Let us see few numericals related to it. Please, you can note it down or you can take a screenshot by pausing the video. Okay, thank you. Let us solve few numericals. for the cell Sn solid. Bridge. Platinum. Right? They have given the data. Standard reduction potential of Sn2 positive to Sn. Its value is minus 0.14 volt. This is your hydrogen electrode. Standard reduction potential of hydrogen or standard oxidation potential of hydrogen is assumed to be 0, so we will be taking it 0 only. E0 of H plus by 1 half H2, H plus by 1 half H2, that is equal to 0.0 volt, and they have told you to find the EMF of cell. They have told you to find the EMF of cell. Let us start. First of all, what we will do? We will write the cell reaction at anode, which reaction is occurring Sn2 positive by loss of electron. At cathode, from H plus H2 is being formed by gaining electron, H2 gas. So let us balance it by adding 2 over here, aqueous. Okay. Now net reaction, two electrons got deducted. Is giving us plus H2 gas, right? Next thing we are supposed to do, that is standard potential of cell, that is equal to standard reduction potential of cathode minus standard reduction potential of anode. So over here cathode is our hydrogen cathodic electrode, so H plus by 1 half H2 minus standard reduction potential of anode, that is Sn2 positive by Sn. Value of standard reduction potential of hydrogen is 0 minus, it's minus 14. So answer is standard cell potential, the value of standard cell potential is plus 0.14 volt. Plus 0.14 volt. Okay. Next, cell potential, E cell equals to E naught cell minus 0.0592 upon N log base 10 to concentration of product. Over here products are Sn2 positive, hydrogen is gas. So for gas we will be using its partial fraction, and here it is given 1 bar upon concentration of reactants, Sn, it is in solid state and its concentration will be 1, we will be taking it 1 unity, that is, and concentration of H plus वो है उसका स्क्वायर, क्यों आगे 2 है इसलिए, right? Substituting all the values, E naught cell we have found it out 0.14 volt minus 0.0592 upon 2 log base 10, concentration of Sn2 positive, it is 0.001. Can we write it as 10 raised to minus 3? Can we write it as 10 raised to minus 3 mole? Yes, we can write. So it is 10 raised to minus 3 into partial pressure of hydrogen, it is given 1 bar upon concentration of H plus 0.01. Can we write it as 10 raised to minus 2 molar? Yes, we can write. So it is 10 raised to minus 2 whole square. Okay. Substituting the calculation, 0.14 minus 0.0296 log base 10 to the concentration. इसको कैंसिल करेंगे तो ये हो जाएगा 10 raised to the power 4, कोई -3, 10 raised to -2 का 4 ऊपर जाएगा 10 raised to 4. So 4 minus 3 1, 4 minus 3 1. तो इसका आंसर आ जाएगा 0.11 वोल्ट. सेल पोटेंशियल इज 0.11 वोल्ट. बहुत इजी है, बहुत इजी. You can take screenshot. Okay, let us solve one more numerical. Zero point 001 molar solid bridge H plus aqueous. They have given 1 molar H2 gas 1 bar platinum solid. Standard reduction potential of iron minus 0.44 volt, minus 0.44 volt, and they have told you to find the cell potential or EMF of cell, right? Let us solve it. The same way, first step to write the cell reaction. At anode, which reaction is occurring? Fe solid. Fe is giving you Fe2 positive by losing 2 electron. Cathode over here, H plus electron is forming H2, that is balancing by writing 2 in front of it. Aqueous gas, net reaction writing over here, that is 2Fe solid plus 2H plus aqueous will give you Fe2 positive aqueous plus H2 gas. Clear? Okay, here I am finding out E0 cell, standard cell potential, E0 cell, that is equal to standard reduction potential of cathode, that is of H plus by H2, minus standard reduction potential of anode, Fe2 positive by Fe. 0 minus of minus 44, so that is 0.44 volt. This is our standard cell potential. Now we will find the cell potential. Let us put the formula. E cell, E naught cell minus 0.0592 upon N. The whole cell is occurring at 25 degrees Celsius, right? Log base 10, the concentration of product, concentration of Fe2 positive, this is gas, that means partial pressure of hydrogen, upon concentration of Fe, upon concentration, that is by mistake it was being written 2 over here, and concentration of H plus square. Substituting the values, E naught cell we are having the value 0.44 minus 0.0592 upon n. What is number of electrons exchanged or lost or gained? It is 2. Log base 10, concentration of Fe2 positive 0.001. Again we can write it as 10 raised to minus 3 molar. 10 raised to minus 3. Partial pressure of hydrogen, it is 1 bar upon concentration of H plus, that is also 1 molar. That is also 1 molar. The 1 square. Okay. 0.44 over here. 0.0296 log base 10 to the 10 raised to minus 3. Now what will happen? The ये minus 3 आगे आ जाएगा. This minus 3 will come over here and the value of log base 10 to 10, that is 1. That is 1. Into minus 3 into 1. So your answer will be 0.528. Your answer will be 0.528 volt. The value of cell potential, that is 0.528 volt. And this is your answer. And this is your answer. It is a good numerical and very easy numericals also. So students, आज हमने क्या पढ़ा है? We have seen standard hydrogen electrode. In that we have seen that it is a reference electrode, and with the help of this electrode we can find the standard reduction potential or standard oxidation potential of another electrode, and that will give you comparative value. It will not give us an absolute value because we are getting this value by comparing it with hydrogen. किसी एक के साथ हम compare कर रहे हैं और जिसके साथ compare कर रहे हैं उसकी value हम 0 assume कर रहे हैं. As said by IUPAC. हमने नहीं कहा, IUPAC ने कहा है कि भाई इसको 0 assume करो. After that we have seen the construction. In construction we have seen कि भाई glass jacket is taken in, that platinum bar is immersed, that platinum bar is connected to platinum black foil. From one side hydrogen gas is immersed in the glass jacket, and that hydrogen gas will get absorbed or absorb on that platinum black foil. The excess bubbles will come out. The excess of hydrogen will come out, and that hydrogen gas will attain equilibrium with the H plus ions present in the solution, because in the beaker we have taken H plus ion solution, right? So this was all related to standard hydrogen electrode. I hope you must have enjoyed the lecture and you must have understood it easily. Please keep watching, keep giving comments, and share the video as much as possible. Thank you.